Section 1. Solutions. Chemical or physical change. Chem talk. Changes in matter. Physical and chemical changes. In this investigation, you observed a number of situations that involve changes in matter, both physical and chemical. A physical change involves changes in the appearance of the material but does not involve creation of new materials. A change of a solid to a liquid is a physical change. When the candle wax melted, it may have appeared different, but it was still wax. After it solidified, it had a similar appearance to the initial product. When the ice cube melted, it may have appeared different, but it was still water. Dissolving is also a physical change. When you added the salt to the water, the salt crystals seemed to disappear as they dissolved in the water. However, they had only spread out into a solution. A solution is a homogeneous mixture of at least two different materials. The materials forming a solution are called the solute and the solvent. The material usually present in the largest amount is called the solvent. When the solvent, water, evaporated away, the solute, salt crystals, remain the same as it was originally. A chemical change involves the formation of new materials. The new materials are called products, and the starting materials are called reactants. The process that brings about a chemical change is called a chemical reaction. Chemical reactions are characterized by a number of changes, including color changes, the formation of a precipitate or gas, and in many cases, a release of heat or light. Chemical changes are usually not easy to reverse. When you burn the wooden splint, you could not put the charcoal and gases back together to form the original splint as you could when you simply broke the splint into pieces. Saturated and supersaturated solutions. The solution your teacher used in the demonstration was a supersaturated solution of sodium acetate. You probably recognize the term saturated. When something is saturated, it is full. A saturated sponge is full of water. It can't hold any more. A saturated solution is one in which no more solute will dissolve in the solvent at the given temperature and pressure. To say that the sodium acetate solution is supersaturated is to say that it is overfull. A supersaturated solution contains more solute particles than it normally would under the given conditions. Not all solutes will form such solutions, but if sodium acetate is added to hot water until it is saturated and allowed to cool slowly, all the solute will remain in solution at the lower temperature. However, this supersaturated solution is unstable. By introducing a seed crystal, the excess solute particles begin to crystallize and come out of the solution as a solid. Concentrations of solutions. One way to quantify the amount of a solute in solution is by measuring its concentration. Concentration is a measure of how much solute is contained in a certain amount of solution, usually a liter. This way of describing solutions has the advantage of being independent of the amount of solution involved. In chemistry, concentration is measured in units of molarity, which is abbreviated as M. Molarity stands for the number of moles of solute that are dissolved in 1 liter of solution. Molarity equals number of moles of solute divided by 1 liter of solution. Again, molarity equals moles of solute divided by 1 liter of solution. For example, when 82 grams of sodium acetate, which formula weight equals 82 grams per mole, is dissolved in water to make 1 liter of solution, this is a 1 molar solution. In a similar manner, 5 grams of sodium acetate, 0.0610 moles, dissolved into water to give 100 milliliters is 0.610 molarity. Molarity and dilution. At the end of this investigation, 150 milliliters of liquid gas sodium silicate solution was added to 400 milliliters of water. This is called dilution. Chemists often have to dilute a more concentrated solution with a solvent, such as water, to make a less concentrated solution. For example, if 100 milliliters of 1 molarity, which is this, hydrochloric acid is diluted to 1 liter with about 900 milliliters of water, its molarity would be decreased by a factor of 10. It would now measure at 0.1. Okay, because what they're doing is they're taking the number of moles of solute divided by 1 liter of solution. That's how they're getting that. Because what you're looking for is the molarity. Alrighty. There's a simple relationship between molarity and volume. Okay, so M is molarity, V is volume, which is used to calculate dilutions. And again, molarity 1 times volume 1 equals molarity 1 times molarity 1 times volume 1 equals molarity 2 times volume 2. Molarity 1 and volume 1 are the initial molarity and volume of solution 1. The more concentrated solution, molarity 2 and volume 2, represent the final molarity and volume of solution 2. The less concentrated solution. The dilution of 1 molarity HCl above can be stated as, what volume of 1 molarity HCl is needed to make 1 liter of 1/10 molarity HCl? Using the equation, 1 molarity times volume of solution 1 equals 0.1 molarity times 1 liter. Solving for volume 1, 0.1 liter, or 0.1 liter is also 100 milliliters. That's what they're saying. Polymers. The chemical material that you were working with when you investigated the absorbency of the diaper was sodium polyacrylate. It is a chemical compound called a polymer. It is made up of many, which is another word for many is poly, repeating units of a smaller group of elements, the monomer called acrylate. This particular polymer has a unique property. It will absorb more than 800 times its own mass in distilled water. The fascinating ability of this polymer, sodium polyacrylate, to absorb large amounts of water has led to its use in a number of commercial endeavors. Okay, that means a number of business and organization products and things like that. So using the polymers in commercial products. Okay,